Hey folks, I'm Alex and I'm going to talk you through a simple notebook continuous integration workflow. So the first part of this talk is just going to be showing you how to set this up with the framework that I've built out of the box. And then I'll talk you through some of the internals so that you know which tools you can use for putting together your own frameworks. Okay, just before jumping into this, I want to get us up to the same level on what continuous integration is. So the problem we're solving is ensuring that every time a change is contributed to a project you're working on, in response to that change, you get some automation, you get feedback on if the change works, and you get integration with your production workflow. So if you're automating a task, every time code is contributed, that new code is used for the next time the task is run. Okay, so the first tool that I'll be talking through is Treebeard, which is the framework that I'll put together for simplifying the setup of a continuous integration solution. And then I'll be talking through GitHub Actions, Papermill, and Repo to Docker, which are all open source tools. They're what Treebeard is built upon, and they're tools that you may want to use directly for automating notebook execution yourself. Okay, so I've put this talk together in a way that, despite it being short, can let you follow along and actually just set up your own workflow. So the first thing that you'll need is a repo with a few files, and you'll have a workflow YML. So that's this first one at the top, and GitHub reads that to provide you with the behavior necessary. Every time you push your repo, you get execution and response. And for your actual project code, you'll need a notebook, preferably a Python notebook, and a requirements.txt file. And if you check this repo that I've linked, you can find a repo that's already set up, and you can fork it and try it out yourself. Okay, so you've got a notebook file, a requirements file, and a workflow YML. The workflow is probably the thing that you're least familiar with. So assuming you don't have any experience with GitHub Actions, I'll talk you through how it works. So the first thing you should look at if you come across a workflow YML file is the trigger section. And that is the part indented beneath the on word. And this workflow file has two triggers. So there's a push trigger, meaning that every time a reference is pushed to your repo, it invokes the action. And there's also a schedule, meaning that in this case, on a weekly basis, the workflow will be triggered. And this way you can both have your notebooks run when changes are made, but also if no changes are made, you may want to run every week because the data changes, and you may want to keep the notebooks in sync with data, depending on what you're doing. So the trigger is the first part to look at. And when the trigger is invoked, the jobs are run. And so the jobs are the second part of this file. You can see here that there's a runs on statement that will determine the machine that the workflow runs on. And in this case, it's Ubuntu. You can use this statement for hooking up your own runners. So if you want GPU accelerated runners, you can integrate them with that. And finally, you've got steps. So steps are going to be a series of actions or scripts that are run. And you can see here we've got a checkout action, a setup Python action, and a Treebeard action. So more on that in a second. When you actually run this action, so when the repo is pushed to or every week, you'll have an entry in the actions section in GitHub. And you'll see here that there'll be one block on the left for each action that's run. So setting up the job, checking out the repo, setting up Python, running Treebeard. And if you go into each section, you'll find logs. And so in this case, you can see that great, our notebooks have run. So our continuous integration workflow has been set up end to end. We just put 3 files in the repo, we push to it, and we've got confirmation that it's still working. And you may have actually successfully automated a task at this point. But sometimes it's not quite as simple. So you may come across issues where you've got runtime errors in notebooks, like the first example, in which case you get you should probably run the notebook locally to see if you can find the issue. You may have missing requirements in your requirements.txt, and Treebeard is quite helpful in stating if a notebook has pulled in a requirement or multiple requirements that are not located in the runtime. And one of the awkward issues you might have is this last one, where if you've frozen a requirements file, you may have trouble with requirements not existing on Ubuntu that did exist on OS X. Check out the link at the bottom. I've written a blog post on Python dependency management that should hopefully nip any issues like that in the bud and help you get things running with a green check mark the first time. Okay, so a little bit into the nuts and bolts of how this works. So GitHub Actions is the framework that is really deeply used here. And you can see that despite the fact that this file isn't the most simple, the behavior that it's providing would require a lot of complexity if you weren't using this framework. So looking at the steps, the first step we have is using a Google Cloud Platform action. So you could find the repo for this action and look at how it works. But all you need to know here is that it takes 3 inputs that we're providing. So a project ID, a service count key, and a flag about credentials. And we never had to install the Google Cloud Platform SDK. We never had to set up ourselves. This action has provided a really nice adapter to get us set up with it. And beyond that, you can see that we've used some really common actions. So one for checking out the repo, because actions don't by default have the GitHub repo available to them, and also installing Python. And we're running a shell script to install dependencies, then running Treebeard to actually execute the notebooks below that. So the last action used there was Treebeard, and to show you how it works under the hood, every action is just a repo with an action YML file in it. It provides the metadata. Most importantly, though, it provides inputs, so parameters that you can pass in. And once you have this in your repo, you also need some implementation files, but this will allow people to use your action in their own workflow files. But the important thing to know here is that beyond this action YML, action is essentially a wrapper around a CLI tool, any other developer tool that you could use on your laptop from the command line. The action actually solves the problem of ensuring that a command line tool can run nicely in the cloud, because quite often you run a CLI tool in the cloud and it fails because it's waiting for user input or a dependency is not installed. But if someone has built an action around a CLI tool, such as with Treebeard here, you'll know that it can install it on a GitHub action worker. So it calls pip install for you under the hood, and it then configures it. So the action itself is just a TypeScript file, and that is calling command line tools under the hood to save you from having to do that yourself when you're implementing your workflow. Right, so that's how we actually get this Treebeard Python library invoked, but Treebeard is not responsible for running the notebooks directly. For that, a tool called Papermill is used, and Papermill is really well supported, configurable notebook execution library built by Interact. And you can see here that it's got a Python SDK, which Treebeard's using, and you can use this yourself. There's also an equivalent command line interface, and it works with different kernels, with different timeout parameters, and basically there's as much configuration as you need. So if you've been using NB-convert, I recommend you look at Papermill instead. It's built exactly for this problem. Check it out. So apart from execution, how do you get all the Python dependencies in one place? Well, the thing about Python is there's so many different ways of specifying packages. You can have requirements.txt, you can use pipenv, you can use conda, and one library which abstracts all of this complexity away is repo to Docker. So as it describes, repo to Docker will take a directory that it's in, search for dependency files, and then construct a Docker image, which is a really reproducible way of running any type of code, but specifically Python environments. So you can see here that this is code that Treebeard uses for building up a command line statement for repo to Docker, and it will run this on the repo which you're using the GitHub action on. And this will give you a working Docker container with all the Python dependencies that you've put in your environment YML or your requirements.txt. And when Papermill is run, all of these dependencies are available. So repo to Docker is well tested. If you've ever used Binder for trying out people's tools on public GitHub repos, then you will have used repo to Docker via Binder. Okay, so I just shot through a bunch of tools. To summarize, at the bottom level of this stack, you've got GitHub Actions, which listens to the repo and lets you hook up events. GitHub Actions works with a marketplace full of actions, some created by GitHub, some created by others, such as ones checking out the repo. Treebeard is just a GitHub action built on Node.js that will automate notebooks. It works by calling a command line tool under the hood, which is a Python package. And that Python package uses repo to Docker for building a working Python environment with all the dependencies necessary, and Papermill for executing the notebooks. So if you're interested in finding out more, check out the Treebeard repo. It's a top link. There's also the JupyterCon example repo, which I linked earlier, if you want to just try out something which you can fork. And if you've got any questions about this, you can find me on Twitter. You can also find me on Gitter, which is linked from the GitHub repo. I'm always happy to take questions on this. Thank you very much.